Thank you, Logan, for the introduction, and thank you for everyone being here, either virtually or in person. I feel very blessed to be able to be here today and celebrate the Django community with all of you. So before starting the presentation, a bit about me. I am from Montreal, Canada, and I've been contributing to Django for about 10 years. You might know me better, not necessarily by my name, but by my Charette S handle on GitHub and the avatar that you see on the right. I started contributing Django 10 years ago, but when I started, I mostly focused on the French translation issue that we were working, and over time, I slowly dipped my toes into the ORM and migration stuff. As a day-to-day job, I work at Zapier as a staff engineer. I'm not sure if you know about us. We're a no-code automation tool, and the mission of the product is to make automation work for everyone. We're about 700 people working across 40 countries, and we're doing so all remotely. Zapier uses Python and Django internally a lot. We have a large Django monolith that we're trying to break into service that some of them are using Django as well, Python. And we do make an extensive usage of the ORM internally against MySQL and PostgreSQL. So what exactly is ORM? What does the acronym stand for? It means Object-Relational Mapping, and it's the layer of Python that Django provides that allows you to map entities to database tables. So if you've used it a bit in the past, you might be familiar with that. Things it allows you to do, retrieve data, persist it, filter it, aggregate it, name it. The ORM nowadays is quite powerful in terms of what it allows you to do. It is the abstraction layer as well that allows you to not too painfully switch between backends. So if you're trying to transition from one database to the other, the abstraction layers that aren't put in place should allow you to do that a bit more easily than if you're writing raw SQL. So today we're going to review what I believe were some of the most influential changes, features introduced in the ORM the past 10 years. We're going to focus on that time period because that's the period where I've used Django the most. We're then going to do a technical dive into some of the issues that are still remaining that I believe would be beneficial to solve, and we're going to also try to look at what lies ahead and how we can get there in terms of solving these long-standing issues. So the features I've picked, there are tons of them. Like over 10 years, the ORM has changed dramatically. It has kind of adapted to allow new patterns or fixes issue that user had in terms of adding a lot of boilerplates to fix common pattern when building a web application. So the focus of the features I've selected is going to be on the ones that brought the most momentum in terms of contributions. And the rule of thumb I used was, what are the features that I would have a hard time using the ORM if they were not in it today? So the first one, if you've used, there were a couple of talks even in this edition of DjangoCon talking about the infamous N+1 query problem. So the feature I want to look at was introduced in Django 1.4 by Looplan, and it's perfect related. So if you're not familiar with what it does, it basically allows you to, when retrieving a collection, if there's a multi-valued collection of objects associated to it, you're able to retrieve it efficiently by doing a single query. Prior to the introduction of this feature, it was possible to fetch all of that, but again, you needed a lot of boilerplate to do that, and not all of the parts of the framework that are heavily coupled to the ORM, such as forms and even Django REST framework we're playing, which wasn't around at the time, but other API framework didn't necessarily play well with this kind of boilerplate. So what I found interesting about this feature is that, yes, it solves a real problem, but the way feature were kind of like built on top of is a good success story in terms of contribution. So when it first landed, it was a very minimal implementation. You could pass strings, I would fetch multi-relationship, but that was it. You didn't have a lot of way to configure the queries that were being made there. But over the years, if we look at the release and the feature that were added on top of it, under the hood in 1.5, there was a lot of refactor relationship caching that took place. improvements to make it work better with select related. And nowadays, I have trouble imagining using prefetch related without the prefetch primitive that was added in 1.7. And the API at the point of release of 1.10 had matured so much that what was considered a private API was made public through prefetch related objects. And these are all features that were incrementally added over the years. And there are still improvements that are being made to the feature in the latest release, and things that are still need to be fixed. So yeah, to me that was a big success story in terms of ship the minimal API and let the community decide in terms of like where we want to go and how we want the feature to evolve. The second feature I wanted to look into is transaction atomic and the large refactor that came to allow it to work. So prior to its introduction in Django 1.6, the transaction handling was very hard to wrap your head around, at least for me. You had to use APIs to manually roll back, commit, do proper error handling. That was a very large API, and that was hard to wrap your head around. So yes, transaction atomic is nice and it's something we use a lot nowadays, but I think the biggest change there was in terms of defining what are the expectations if you use the public API in terms of transaction handling, and here's how you can go off-road, and if you go off-road, here's what to expect in terms of things that Django won't do for you anymore. And that is proven to be very useful because if you've had a chance to do any form of triage against issues that are reported against transactions, the boundary between what's supported and what's not is very clear. So we can guide user in terms of defining, is this a bug or is this something that, well, you turn off transaction management, so you're kind of on your own here. And there's also a pattern that you see in other features in Django where they start to mature outside of the framework and they eventually get merged. So you might not know about this, but the atomic context manager that you might be familiar with is something that came from, like, Emmerich took inspiration from another solution that was handling transaction differently in the past. And the same can be said about transaction on commit hook, which was maintained as a third-party application by Carl Mayer prior to being merged in core. The third feature is what I believe was the most influential in the recent years of around the ORM. It's the introduction of custom lookups, transform and expression, and their documentation. To me, it completely liberalized the access to the ORM. Prior to that, it was very hard to wrap your head around about how to do anything beyond what was already included in the ORM in terms of lookups and transforms. So if you wanted to do anything that was not already bundled in this big monolithic ORM that didn't have a lot of entry points, you needed to drop into extra and with all of its pitfalls and the way it needs to, you need to be very careful about how you make reference to objects and how you include joins. It formalized the APIs in terms of what is a resolvable and what is a compilable. So how can you have a reference to like just pass a string reference to a model field and have it result in a join in a column. And here's how you can actually have the objects bit SQL and have it used when the query is generated. So yeah, it made most of the usage of extra obsolete at that point as well. And from that point, we've taken a stance where we've documented that if you have any usage of extra that is not covered by this particular API, you should report it as a bug because we want the expression API to be flexible enough for you to not have to drop into raw SQL through extra. Something we saw as well when this feature was added is kind of like the long tail of contributions, both in terms of bug fixes. In the end, we still move a lot of stuff around. So there were a lot of bug fixes and optimization features that came in terms of contribution. So what you see here is a breakdown of the track ticket by their kind, the ones that were attributed to the ORM framework. These bug fixes, since the API was kind of clearly defined in terms of what is resolvable and compilable, it made it easier for new contributors to come in and fix bugs that would have been very hard to fix otherwise in the ORM because the code base was so intimidating. The next feature is what I would qualify as expression v2, where we took the concept further in terms of introducing subquery, exist, filtered expression. These really build on top of the giant work that went into introducing expression. So if you think of outer-ref that is used when you create a subquery to refer to an outer column, that wouldn't have been possible at all if the expression concept had not been existing. It also provides you a way to have more control of joins. Filter expression does that. Prior to that, there was no way to tell the ORM about, oh, well, I want to be using joins in a certain way, and that's something that users that are more familiar with SQL have been asking for a while. Just give me a way to tell the ORM how it should join the data. It also made even more usage of extra obsolete by having more ways to do joins and have a bit way to inject subqueries as well, which sometimes the queries that the ORM is going to be generating are going to be very hard for query planners, the way database interpret SQL and actually retrieve the data for you to make it efficient. So if you have more ways to help the database into retrieving the data efficiently, you need to rely less on extra, and that's something this feature did. And fortunately or unfortunately, these expressions are still required nowadays to work around or circumvent long-standing ORM issues or limitation, and one of them we're going to go into very soon. The last one is kind of like more of a big bet. It was introduced relatively recently in 2019. It's introduction of constraints. It kind of built on top of all the work that went into expression, but it took it a bit further in the sense that previously an expression had already always needed to be resolved in the context of a query, but in this case, it was resolved in a very limited scope where join were not allowed and you were not allowed to refer to columns from other models and so on. It also paves the way for possibly deprecating unique together in the future. I know this is something we tried doing with indexes by trying to deprecate the index field on constraint. And I think it also paves the way to revisit model validation, which is kind of like a contentious point of discussion about is it a good thing, is it not? Because once you get an object that points at a constraint, you can kind of like switch the way you deal with data validation that is enforced by constraint in the database. If you try to insert the data and an integrity error is thrown at you, well, you at least have an object in the Django realm to surface. You don't need to do prior validation. You can rely on the database and turn that into proper message for user consumption. So this was a review of features that I thought changed the way we use the ORM. There's a lot of them, so if you've contributed to one and it was not mentioned there, it's not because it's not important, it's just because there was only a limited amount of time that could be spent on this. So now that we've looked about the good parts, I think it's worth looking at things that we could do better or things that we've known are not so good that we know for a while. So the first one I want to look in is the way Django deals with multi-value relationships. So to understand what a multi-value relationship, say that you have a book model that refers to author, that's like the typical example that is usually used to explain foreign keys and how they are queryable through the ORM. So assuming the book has a foreign key to author and a second one for co-author that is optional. If you look at the relationship from the book perspective, the book has a single author. So we'll say that the relationship is single valued. But if you look at the relationship from the other side, the author can have multiple books. So we'll say that the relationship is multi-valued. And this is what we're going to be looking into. So the way Django deals with multi-value relationship is surprising to a lot of newcomers, or at least the ones that I've had a chance to mentor or introduce to Django. When you try to either filter or order by or annotate against a multi-value relationship, you're going to get duplicate results from the base model you're querying from. And usually when I'm helping newcomers with Django, the default option there is just use distinct, right? You're going to reduce the set of objects that are returned, and in most cases, it's just going to work. But that's still a very surprising default that only happens when dealing with multi-valued relationship there. So if you look at the example, if you were trying to filter out the author that have a book that contains a particular keyword, if the author happens to have multiple books matching the criteria, then you're going to get the author multiple times in the query set that is returned to you. And there are ways the ORM could do a better job there in terms of like preventing dupes from being returned. These are known. But the thing is, this feature has been around for so long that taking it away has a lot of impact. We need to account for that. And it's somewhat desirable as well. So if you're using values or you're not dealing with models, it might make sense. You might want to return like all the books from that. And it's also desirable in certain contexts in the case of aggregation. So if you're trying to retrieve all author and you're trying to annotate them with the number of books they have authored, in this case, the usage of an aggregate function would result in a group by. So the duplicate results will all get merged together, and you won't run into this particular issue. But this feature is useful till a certain point, because there's this long-standing issue where if you use more than one aggregation, if you refer more than one multi-value relationship when either doing filtering and you try to or ordering and you try to retrieve the results, what you're going to get is not what you would expect. So in the case of trying to retrieve all the author and trying to retrieve all the count of books and the counts of books they have authored and co-authored, both the book count and the co-author count are going to be the same value. They're going to be a product of each other. And the reason for that is the way the ORM builds joins on top of joins when building with multi-value relationship. You're going to start from an author row, which is going to be turned into duplicate books, and each of these duplicate books are going to be turned in dupes. So what you actually get are dupes of dupes, and the counts that you're getting are going to be the product of each other, which is not something you would the user would expect, at least for Django to do by default. In the case of count, it's workable. You can use distinct. You can use kind of like the same workaround, but it's not possible for aggregates that don't deal with unique values. So in the case of average or sum, that's something you couldn't use distinct there because it doesn't make sense. And it's also an issue that is kind of hard to diagnose. The data the bug will only manifest itself if you're dealing with a data set that, so if you're dealing with multi-value relationship, but most of the time there's a single item, it might be very hard to diagnose, in which case the query that is generated is not right. And with the subquery expression, it is possible to work around, but it's still kind of a foot gun in terms of default behavior. So for this particular problem, multiple solutions have been identified, but they're mostly backward incompatible. So we could warn or error out when more than one multi-value relationships are involved in queries. We could group by, even when no aggregation is involved, so no dupe rows are returned. There's a lot of solution that could be taken there. But the big push over the years has been trying to teach the ORM to be smart enough to don't do these kind of things, so you don't have to worry about it. But it's a very hard problem, and the fact that this ticket has been open for so long speaks for it. There's a lot of ramifications. So if you wanted to use exist, for example, there are some backends that don't work so well with that compared to using join. The second long-standing issue I wanted to discuss has received a bit more focus in DjangoCon Europe this year. So I want to go over it quickly. So to provide you a bit of context, the way field retrieval is performed when using a query set relationship are going to be deferred by default. So that means that if you're retrieving book, the author that's associated to them are not going to be joined against or present by default. And if you want to change that, you need to opt in using select related. On the other side, fields are always selected by default. And if you want to prevent that from happening, you need to opt out using defer or only. So if we take the same model and we look at what happens, if you try to select all of the book, you will notice that there's no join, no implicit join that's going to be performed from the ORM. And what that means is that if you try to access the author that's associated with a book, this will incur an extra query in order to do so. And you need to opt in if you want to prevent that from happening. On the opposite side, if you defer the title, so you opt out of selecting title, and you happen to push the book through 3 layers of serialization, and it happens to be accessed later on down the abstraction layer where you're passing the data, you're going to get an extra query by doing that. And this is usually referred to as the N+1 query problem. So if you were trying to iterate over a collection of book by opting out for selecting the number of name, and you're trying to access both the author of the name, you would get 1 query for retrieving the set of objects and 2 query for dealing with the attributes that you've opt out or forgot to opt in order to select. And while there are a lot of third-party solutions to kind of make this problem less of an issue, what the core provides are somewhat limited. So if one pattern that is used to prevent that from happening is to have very good code coverage and use assert num queries, and you hope that there's no cache property somewhere or global state that is in your state, and then you need to make sure the cache is cleared to to make sure that your test actually provides some value and are not just very flaky as your product evolve. You can have a middleware that monitor a number of queries. There are a lot of tools that are outside of core that make the experience, I would say, less miserable, but that also at least provides you some way to fix this problem. So what I'd like to look into is possible ways that we could make things better in core. One of the solutions that has been proposed and has been received a bit of focus is to automatically use prefetch related when a N+1 query pattern is detected. So that would mean that, so you can look at this project and Django Auto Prefetch, and there's also an open merge request for it. But what it basically means is that if you were to iterate over a collection of book and you try to access the author for it, instead of solely fetching the book, the whole collection of author associated with the peers or the collection of book where the book was retrieved will all be fetched in a single query. So that would prevent this problem from happening. It would kind of be an implicit or after the fact prefetch related call that would be made. There are cons though for this particular approach, at least at using it as a default. Not sure if you've used prefetch related in the context of a system that deals with a lot of multi-concurrency, but since the data is retrieved in 2-step, the state of the database is not frozen between, which means that when it gets combined through prefetch related, some attributes that you would expect to be there could result in exception when trying to access them. So in the case of book, if you happen to fetch all the book and you try to access author and you've used prefetch related to fetch the author, nothing guarantees that you won't get it does not exist when accessing the author if the author has been deleted in between. And usually it's not a problem, partially if you're dealing with data that is not being altered a lot. But if you're dealing with a data set that is evolving a lot over time, you might have run into this issue. And something else as well is that it kind of encouraged lack practice in terms of data access pattern. There are very legitimate cases where you want to fetch all the data up and you want to be explicit in terms of how it's accessed, and trying to automate most of that, I think, is kind of doing a disservice to at least some users that could use the ORM as a way to learn more about SQL. The other solution that I wanted to look at is the a way to log, warn, or error out implicit queries. So instead of having the ORM happily fetch data for you, you would at least get a warning or something you can take action on. So there are two packages that have experimented with that. So in the case of book here, you would get either a warning or an error when trying to access an author if you've not select related it preemptively. Same thing with a field where you would have opt-out, it's selecting, and that's a pattern we've used at Zapier when building a GraphQL endpoint that was translating GraphQL into ORM queries, where we wanted to make sure we didn't miss anything. And the way we've used this pattern is to have warning emitted when an attribute is accessed. And just like when you try to update from one version of Django to the other, there are ways that you can elevate the warning to an error, and this is something we do when running the test suite. So we can catch the issue when running the test suite if we have coverage, and we pipe the warnings into a logging facility in production. So we don't get exception in production, but we also get a way to know that we've missed something with our tests. But there are cons to the solution as well, because it doesn't actually solve the problem. Yes, it's going to yell at you about, oh, you've done something wrong, but that's maybe not the user experience we want for all the newcomers. They might be way more happily when you're prototyping a project, or you're not necessarily interested in knowing about SQL. You might be more interested about having the framework take you by the end and make sure that you can defer this problem to later. And it also requires some form of opt-in to maintain backward compatibility, partially in the case of raising exception. So what I think we need to do here is kind of like step back and think of a generic solution. If we look at what other frameworks do, the Python field, SQL Alchemy allows you to define a lazy field option for defining a per field strategy, and allows you to retrieve that or add a context manager or some form of like query where you could specify default. So I think that as a framework, we know about like the whole landscape of solution, but what we should focus on first is adding a proper entry point. And then from there, possibly ship a couple of solutions in core and let the ecosystem of third-party application use the entry point and provide feedbacks in terms of how things should be done better. And something that surprised me as well when I did the research for this particular issue is that this problem is not new. Like a lot of problems with Django, they've been discussed a lot in the past. And I'm going to share the slides afterwards, but there is a Django developers discussion that dates from 2013 that talks exactly about this problem. The last long-standing issue I wanted to look at was how Django is kind of somewhat limited in terms of how it allows you to define a relationship between entities and models. Sure, if you want to have a foreign key or you know exactly what your database model looks like, you're going to be able to use foreign key, one-to-one field, many-to-many field. These are certainly very useful, but when you're defining an application, there's a lot of business logic that goes way beyond the constraints that you'll be getting at the database level. And the introduction of filter relation kind of dipped its toes in there, where you could, when you're generating a query from an existing relationship, take it and limit it to a smaller scope, so you can kind of like embed some application level in there and reuse this alias when building queries. But if you look at what third-party packages have done in terms of pushing the idea further, Django Relativity and Django Reverse Unique, which was maintained by NC, which is one of the Django core contributor mostly to the ORM. I think this is something that the ORM would benefit a lot from having. So what I mean by that is that if you're defining a book, it might be useful to have an alias that encapsulate this concept of, oh, give me all the books that were published the same year, or in case of like you have a lot of translations that are mapping back to a book, you might want to limit them to the current activated language. But you might want to do that at the model level, because when you do it at the model level, the particular alias remains available for all of the ORM utility. So if it's defined at the model level, it means, oh, you can do aggregation on top of it. You can do select related on top of it. You can do filtering, prefetch related. So having it available at such a low level allows for a lot of reusability and possibly very hard relationship definition and constraint encapsulation into a reusable alias. So it does improve code reusability, and I feel like it's also much easier to reason about complex data models. You can embed all of that logic on the model level, and from there, you don't have to make sure that, when I'm using this very complex Q object predicate when building this filter, did I miss, did I use the correct lookup in this particular call in my application? And one of the big benefits of it as well is that you inherit relationship caching. And once you have that, all of the parts or ecosystem that revolves around the ORM can benefit from it. And an interesting point about that to finish on this feature is the fact that most of the machinery is already available in the code base. If you've used foreign key and you've accessed it through the reverse relationship like we did when we accessed books from the author model previously, it's already something that the ORM does internally. So it would mostly be a matter of making sure that these API are ready for public consumption, but most of the work is already done. It's more about pushing it through the finish line, making sure that, again, we provide the foundation and we allow the community to build on top of it. And so I went over 3 features, but there's a myriad of them. There's so many of them that have been around for so long. So composite primary keys, support for multi-value selected is something we could do now. Form of generated fields, DB default, DB on delete. If you go on track and you look at these things, users have asked for that for a while. The reason for it is that we're a limited number of people, and it's very hard to commit to a feature, but not only adding the feature, but committing to the long tail of issues and regressions that are going to be caused by it. So what are the current state of things looking at all of these features around? It does take a long commitment to see this feature through. When you come, you have to advocate for it. You have to show that there was some form of adoption, or that the patterns that are used have been proven to work in a lot of contexts, and it's not just kind of anecdotal evidence that it works for you. There are just a small number of individuals who are able to review ORM change. Our fellows are doing a good job about doing that, but it needs to go beyond that if you want to ensure that there's proper diversity coming from different backgrounds that are using Django, to make sure that we're just not short-sighted on making a particular change. And some of the issues there are just stalled due to a lack of consensus. It's very hard to move things forward when you have just a small, limited number of individuals. And last thing as well is that even if expression and introduction made things better, the ORM is still perceived as this undecipherable part of Django, where it's this black box. You get the models, something happens, it goes to the database, something happens, you get back the data. But I think we can do a much better job into making this at least perceived less of a black box, because it's way better than it used to be. And this is what I want to look into here. If you look at the number of contributions, so this is coming from Git commits that were made partially to Django DB models. We can see that there's a decline, but one thing that remains constant is or somewhat constant, or in the same order, is the number of contributors that have over 2 or over 10 contributions. And usually, if you want to get familiar with the internals, you need to be keeping track there. And over the years, it has been a constant. Even when NC or Malcolm was around, there's just not a lot of individuals who are able to or are committed to reviewing these kind of changes. So how can we change things? How can we make things better? I think that the problem is not different than then when you inherit or you move to a company or inherit a very complex code base, right? That is pre-documented in some sense. So this is the approach I've taken, or this is how I perceive how we should approach a problem. So I think the first thing we should do is just document the ORM internals. It doesn't have to come with this, oh, Django will support it going forward, but at least just supporting, documenting a bit of it, and putting this big disclaimer on it saying, oh, this is still somewhat of an unstable API, not a private one, but an unstable one, and we want your feedback on it. I could do a long job into onboarding new contributors that are interested into making things better. I think it could also highlight the currently undefined behavior that we have in the ORM, because sometimes when we add a feature, we try to think of ways of, oh, this feature is going to interact with this other one, and we need to add some test coverage to make sure that it works well. But when some issues are brought up, it takes a bit of time to define, oh, well, what actually should happen there. So I think it could go a long way documenting the internals into making sure that we're more focused or aware of interactions between components of the ORM. It would also be a nice way to kind of like rediscover or formalize reasoning behind years-old decisions. There are things in the ORM now that if you go through, you do some form of like Git archaeology, so you go through track, you go through mailing list, you do Git blame, you will get all you need to understand why the ORM is made in a certain way, but it's so long, it's not something we should expect contributors to go through if we expect them to make change to the ORM. And finally, documenting it would be a way to define the expected behavior beyond the test suite. Because when we make change to the ORM, most of the time it's, oh, well, does it pass the test suite, like the change you made? But I think that it should go way beyond that in terms of providing a quality, enhancing the quality of the software we ship. And another way to do that, having had the chance to deal with code base that were hard to approach, is start by adding typing to DjangoDB models internals. I was someone that was against the DEP 484 when it was first proposed, partially because I feared all of the complexities of what comes with typing was something I was not that used to at the time as well. But if you look at it now, it has matured a lot, and partially the introduction of typing protocol is something that would work very well with how the ORM does a lot of like duck typing with regards to resolvable and compilable. So I've kind of like changed my mind on the subject, at least for the internals, because I've seen the benefits internally at Zapier and in other projects I work on. And it will also go a long way into reducing the long tail of type error and attributes error that we always get when we do release candidates, or we release the first version of a major release. These are things that are avoidable by using typing, because the linter will yell at you if you forget about about a particular case. And the last one, again, is mentoring. If we want to increase the number of individuals who know about the ORM, we need to have the ones that understand it now pass it along and make sure that new contributors are able to get onboarded and are able to provide value to the community, at least through the ORM. So I think we should focus on incremental improvements and refactors, and ideally would get to a point where if one individual is interested, or one or more individuals is interested in contributing to the ORM, having a way of following a bit the summer of code model, but per release, would be something that I believe could work in terms of like commitment from the small number of individuals who currently review change to the ORM. And this is something I'm interested in doing, at least one individuals per release. So thank you very much. This was my kind of like naive take on like how we can make things better. I know that it goes way beyond these words. I'm happy to discuss it further off stage and during sprints. I'll be there during the sprints if you want to speak ORM, you want to look at the ORM, you have a completely different take on the subject. Yeah, so thank you for your time.